Hi everyone, my name is Arna Rajput,
My name is Venkata. My name is Diego.
and this is our boat trip project. So, what is this project about? Our goals and steps. So, our purpose is to explore our intended majors, relate ocean related topics, and study how chemistry plays a part in it. Our project. One of our goals is to explore how the weather can affect the conductivity of tracking systems in ships and how computer engineering can help solve the problem. So, what are the effects of weather on ships, especially their tracking systems, and how might computer engineering help track the effect of weather on ships? So, how does this interact with the water slash coastal environment? So, ships are a major industry in the water environments. It helps transport thousands of goods and people per day, and they're a major economic sector in the maritime industry. Weather can also play a major part in detrading ships and their electronics inside. Due to this, there can be a major danger for people and goods if something goes wrong. It can also cost millions of dollars to keep up with maintenance of the ships. By researching how computer engineering can help with this problem, it can help improve the ship industry and make the water slash coastal industry more efficient and safer. So, how does it relate to chemistry? So, the weather or atmospheric chemistry is a huge branch of chemistry focused on chemical reactions in the atmosphere and how it relates to weather. By studying atmospheric chemistry, we can see how the harsh weather conditions caused by atmospheric chemistry can impact the weather ships sail on. It can also help investigate how chemical reactions such as oxidation can cause the deterioration of ships' hardware components. And finally, you can see how computer engineers can study atmospheric chemistry to assess the impact of weather on ships' hardware and tracking devices, as well as prevent ship deterioration caused by weather. Now, my partner Venkata will talk about the duties and agreements in our group.
This slide is about what are the duties and agreements in our group. So our group's name is the Oil Spill Squad, also known as the OSS, and we're composed of three members. Our team manager is Diego, and he was in charge of making sure the team was organized, making sure that everyone knew what they were doing, and basically leading the team on this project. Then our project manager, Arna, is in charge of making sure all of our submissions and making sure that everything we produce is up to the level that it should be, and making sure that there's no mistakes, and making sure that everything is organized in the products, and making sure we submit them on time. And then I'm the research facilitator, and I am in charge of making sure that everyone knows how to research what we should and making sure what we have to research, and basically making sure that all the information is gathered and making sure that everyone knows how to get that information. And situations that we challenged, that challenged us while we were doing this project was having to coordinate time when we can all work on assignments and times that fit our schedules. Everyone has different schedules, everyone has different times. So we faced a lot of problems in making sure that everyone could come together and work on this project. And what happened was we just went to our team charter that we worked on before. And one of the main points in our team charter was communicating our schedules and times so we can find times to work and meet. And this really helped us make sure that we can work around other people's schedules and come together. And then another one was having a full understanding of what we had to do for assignments and how to do them. Again, using this team charter and the agreements, we communicated any questions we had, communicated our individual roles on assignments, making sure that everyone knew what they were doing and helping them with their parts on assignments, and going through the assignment after we finished to see if we met all the guidelines or not. So we have five initial proposals that we had before. The first one was the oil on ships can be affected by weather conditions such as sunlight and precipitation. Second one was the variations in weather affect the viscosity of the oil on ships. The third one, which we chose, was the weather can affect the conductivity and tracking systems of ships. Fourth one was chemical changes in oil due to oxidation can cause inaccurate tracking systems. And the fifth one was data systems can be used to predict how weather influences navigation systems. And so our thesis from the weather can affect the connectivity and tracking systems on ships was oil tracking ships can heavily rely on complex electrical systems to monitor, navigate, and transport large batches of cargo. And these systems are really vulnerable to unexpected weather conditions. Electrical conductivity is the backbone of every ship's operational system. And when we are faced with harsh weather conditions like harsh rainfall, hurricanes, or any other kind of bad weather conditions, it can cause malfunctions, data loss, and even become a safety hazard. And this presentation will explain the relationship between weather and how it affects the electrical conductivity of oil tracking ships. The reasons that we chose this thesis because all three of us have members that are working in the IT field and exposed us to more real world technological problems. This led us to wanting to research a practical problem that IT professionals may face in critical industries such as the impact of extreme weather on electrical systems of oil tracking ships.
This is our findings and pictures for our project. We have our boat trip pictures and coordinates right here. We have the Gulf Copper, the Royal Caribbean Cruise Terminal, the Selma Boat Wreck, and the other two we have Pelican Island Cut and Texas City Dike. And the finding that we found most related to our thesis was the corroded ship, because this shows that the long-term effects of the harsh environmental conditions of a ship. And it shows that corrosion is caused by chemical reactions between metal, salt water, oxygen, and moisture, all of which increased by severe weather conditions.
So, what is your scientific evidence from the literature? So, for mine, according to Pacific Yacht Systems in 2004, in order for a ship to perform well, the electrical system must be clean and free from moisture and corrosion. This company explains that, quote, in a marine setting, electrical equipment can be damaged by exposure to fresh or salt water. Such exposure reduces performance ability and increases the likelihood of future equipment failure, unquote. This shows how, no matter the kind of water, it will always be a disadvantage to the system's efficiency. An example of this is when moisture gets into the electrical components of the ship, the copper wire will begin to oxidize, generating a greenish tint, which creates resistance. This means that the resistance is generating heat in a direct relation to the same amount of current flowing through the metal that's been oxidized. The biggest drawback of this process is that it stays inactive, so until the electricity has been turned on, no one will be able to tell that this oxidation occurred. However, once the electricity has been turned on, it can quickly turn into a fire hazard, damaging the ship's electrical systems and cargo. Computer scientists need to think about developing more intricate algorithms that can account for the spontaneity of weather conditions. Adding on, artificial intelligence, or AI, can be used to easily enhance and explain data from sensors on the ship, especially in conditions with low visibility.
And following that, according to Britannia, extreme heat can cause various types of risks, such as the technical well-being of the ship due to crude oil being destroyed. Britannia states that heat waves are prolonged periods of abnormally hot weather, typically associated with stationary or slow-moving high-pressure weather systems. If the locations of heat waves are not predicted carefully using weather systems, vessels transporting oil can be severely damaged and become dysfunctional. Computer engineers on a vessel are able to predict the weather utilizing software that locates where the temperature is at its highest in the area. Another major potential weather hazard that could negatively impact a transportation vessel are rogue waves, also known as extreme storm waves. Storm waves are extremely common, and unaware vessels are bound to encounter them, as Britannia states that it is now believed that rogue waves are more frequent than previously believed, and there could be as many as 10 rogue waves forming in the world at any given moment. These types of storms are extremely dangerous to ships, and more specifically can cause major damage to the exterior of a vessel. This is why computer engineers that oversee the hardware and software of a vessel are very important, as having the ability to predict the weather and seeing the changes it goes through being an essential asset to a vessel carrying vulnerable substances such as oil.
According to a peer-reviewed article titled Review on the Impact of Marine Environment on the Reliability of Electronic Packaging Materials, it can be seen that moisture does not have a beneficial impact with ships' electrical components and hardware, like when it says in the article that high humidity conditions degrade the mechanical integrity and interfacial stability of electronic packaging materials, increasing their damage progression and ultimately severely compromising their long-term reliability in marine environments. In this article, the article clearly explains that high humidity conditions have a negative impact on ships by ruining the stability of electrical components and systems and causing the lifespan of its systems and the ship itself to decrease. With this, there can be many negative effects on ships, as if something happens with its electrical and computer systems of a ship, that will cause the whole ship to be in extreme danger and put the people and the environment at risk. And if oil gets leaked into the environment, the marine environment will get impacted negatively. More specifically, as the article writes, the humidity will affect the ship's materials much more greatly than normal weather conditions. With this being said, the article clearly talks about how, because of the increased humidity, the ship's elastic modulus and yield strength will decrease, in which in return will cause the ship's resilience against deformation weaker, causing the overall lifespan of the ship to decrease. All of these issues can cause serious problems to the functionality of the ship's electrical system and ship's overall durability, and cause dangers with economic problems to ships and companies.
So computer engineers can help all of these by first creating systems in ships that will be able to track the amount of impact humidity is doing to the ship's components and thus in return be able to track the ship's health and provide useful information about how to help solve these issues. Computer engineers will also be able to help create electrical systems that will be more well suited to deal with extreme humid environments and thus create stronger electrical components in ships that will make the ship safer and create a more long-lasting ship. We can see with all of these improvements in ships' electrical systems and helping to track the ship's health, computer engineers will have the ability to provide massive amounts of help to this issue and hopefully make the adverse effects of human environments more manageable. So finally, to end off this presentation, various weather conditions can alter the conductivity of a vessel's electrical system. It's detrimental to a ship's performance ability and can become a hazard if not treated accordingly. Computer engineers need to reflect on improving the electrical system's hardware and improving sensor calibration to make it easier to predict any incoming weather calamities. This is our works cited page, and we hope you enjoyed this presentation.